For decades, astronomers have kept their focus fixed on one of the brightest and most mysterious stars in the night sky. This star, known as Betelgeuse, is a colossal red supergiant located in the shoulder of the constellation Orion. It is not just any star. Betelgeuse is enormous, with a size over 700 times that of our Sun, and it carries nearly 20 times the Sun's mass. Because of its immense size and unstable nature, it has long been understood that Betelgeuse is nearing the final stages of its life, precariously balanced on the edge of collapse. Scientists have known that this star's end was inevitable, but the precise timing remained a profound mystery, something that could take place any time within the next few 100,000 years. Until recently, the idea of witnessing this cataclysmic moment, the death of a giant star, was something many thought impossible in human timescales. Thanks to the unprecedented capabilities of the James Webb Space Telescope, however, we are now observing this extraordinary event in real time. What we are seeing is the birth of a supernova, an incredibly violent explosion marking the end of Betelgeuse's life. This explosion unleashes an enormous blast of energy, sending shockwaves, rippling across space and illuminating the cosmos with a brightness that can rival entire galaxies. This rare, unfiltered look offers humanity a unique window into the powerful forces that shape the universe. The same forces that forge galaxies, sculpt planets, and create the very elements essential for life itself. This is not a scene from science fiction. It is the universe sharing one of its deepest, most fascinating secrets as it unfolds right before our very eyes. This event isn't just another routine observation of deep space. It's a once-in-a-lifetime phenomenon, the closest supernova humanity has ever recorded with such clarity. What the James Webb Space Telescope has uncovered challenges much of what we previously thought we knew about stellar deaths. Betelgeuse isn't simply a large star. It's a true monster of the cosmos. Its massive size, instability, and recent behavior have kept astronomers on high alert. Back in 2019, Betelgeuse dimmed mysteriously, causing a global buzz in the scientific community and the media. Was this the beginning of the end? Was the star signaling its impending collapse? Now, with Webb's infrared vision, we are seeing details never before accessible. Signs of a real-time collapse, including massive releases of energy, boiling and turbulent surface layers, and magnetic fields twisting and spiraling into chaotic patterns. Betelgeuse isn't quietly fading away. It's undergoing a dramatic transformation that we can observe directly. For many months, the Webb telescope has locked its gaze on Betelgeuse, piercing through thick layers of dust and gas that had previously obscured these phenomena from view. The data streaming in is nothing short of astonishing. Massive convective bubbles, some larger than Jupiter, burst across the star's surface. Plumes of superheated plasma jet out into space at incredible speeds, sometimes thousands of kilometers per second. Deep within the light spectrum, scientists have detected a shockwave racing through the star's outer layers, an unmistakable sign that the star is in the final stages of collapse. This is not a theoretical model or a computer simulation. It is the live, unfolding anatomy of a supernova, happening just 642 light-years away from Earth. Unlike the supernovae observed in distant galaxies, Betelgeuse is in our cosmic neighborhood, close enough that its explosion could outshine the full moon and even be visible during daylight hours. The importance of this proximity cannot be overstated. For the very first time, astronomers can study in exquisite detail the physical processes behind a star's death. We are seeing how the core collapses under immense gravity, how new elements are created through nuclear reactions, and how shockwaves propagate through the interstellar medium, reshaping space around the star. This observation goes beyond simply watching a star die. It reveals the fundamental processes that gave birth to everything in the universe, including the carbon, oxygen, and iron that form the building blocks of planets, life, and even ourselves. What the James Webb Telescope has captured is far more than a spectacular cosmic event. It's a key to unlocking how galaxies evolve, how planetary systems come into being, and how the universe continually recycles matter to create new stars and worlds. With this unprecedented data, scientists can now build far more precise models of how stars die, and even hope to predict future supernovae by spotting early warning signs long before the final explosion. But the discoveries do not end with visible light. Webb has detected ripples of energy and streams of high-speed particles blasting outward, heating the gas surrounding Betelgeuse and reshaping its massive dust halo. There is even evidence of a gravitational ripple, a disturbance in space-time itself. If this gravitational wave signal is confirmed, it would mark the first time that a visible supernova is directly linked to gravitational wave data, opening a new window into the nature of matter, light, and the fabric of the universe itself. This groundbreaking link could revolutionize our understanding of fundamental physics. Yet, even with all this information, the biggest mystery remains. What exactly will be left behind after Betelgeuse's explosion? Will it become a neutron star, a black hole, or something else entirely? Webb's observations suggest that the star's collapse is uneven, with magnetic chaos and some material falling inward rather than exploding outward. This has led some scientists to speculate that we might be witnessing the birth of a new kind of cosmic object, one theorized for decades but never observed, a transitional relic between a neutron star and a black hole. If this is true, Webb may have just captured the first glimpse of an entirely new class of celestial phenomena. Given how close Betelgeuse is to Earth, many have asked whether this supernova poses any danger to us. Fortunately, the star is far enough away that its explosion will not directly harm our planet. However, the blast will send waves of radiation, gamma bursts, and electromagnetic turbulence across many light years, affecting cosmic dust clouds, reshaping interstellar structures, and even altering how starlight reaches us here on Earth. This could permanently change how we see and understand the cosmos. Betelgeuse serves as a powerful reminder that even the most massive, seemingly eternal stars have lifespans and ultimately fall. Yet, in their death lies the seed of new life. The remnants of this explosion will seed the cosmos with heavy elements, from which new stars will form. New planets may come together, and perhaps entirely new forms of life will arise. Among Webb's extraordinary findings is the detection of rare elements such as technetium and rhenium, elements forged only in the most violent stellar explosions. These elemental signatures serve as cosmic breadcrumbs, allowing scientists to trace the journey of matter from dying stars to newly forming worlds, and even into the molecules within every cell of our bodies. This story is not just about Betelgeuse itself. It is a story about us and the very origins of life. Though Betelgeuse will never shine again in Orion's shoulder, its light fading into a nebula of swirling dust and gas, it has left us with something far more valuable than brightness. It has given us a profound insight into the workings of the universe. This moment is not an ending, it is a cosmic rebirth. Thanks to the James Webb Space Telescope, humanity was there to witness it. In the silence of space, a star has collapsed. Yet what remains is a cosmic message, one that began long before Earth existed and will continue to echo across the universe long after we are gone. As we absorb this incredible event, we are left to wonder, what other secrets will the universe reveal, and are we prepared to witness them?